Hi, my name is Jason Wampler, and this is another episode of The Rocket Minute. I bet you thought I was going to say hold on, let me pause this. Bet you thought I was going to say an axe to grind. I'm actually watching a movie. It's called The Many Faces of Death. It's one of my favorite movies. It's a sort of a documentary of sorts. Made in 1978. It's been banned in like 32 different countries. I think it's been banned in this country as well. I live in the United States. Anyway, um, behind me you see some of the small examples of rockets I'm working on. I kind of moving past the kind of moving past the materials research stage of my sojourn into building rockets properly. I want to show you something. This is, oh gosh gracious, you can tell I'm not prepared. Um, the latest example of rocket. It has a wasp waste transition. Um, this is the fuselage. This is the motor housing designed to accommodate 29 millimeter H120. In other words, a 29 millimeter uh, H-size motor that has 120 amps of specific impulse, which is burn burn rate, which is burn time times total thrust, two multiplied by each other. You come up with 120 newton meters of pressure. Uh, an H20 motor in this little teeny rocket will probably get it to about 5,000 feet. This is the total length there and there. I have to fabricate the nose cone, the anchor spool. This is a section of that'll house the parachute, and the nose cone itself is going to be the forward end of the anchor spool. There's the anchor spools that I developed. They have an integrated a heat baffle so they don't burn the parachute. But you know what? Just to double up and be safe, you might want to still install some heat wadding. Never use toilet paper because toilet paper is flammable, and you have burning debris falling to the ground. You can cause a brush fire, so be careful about that. This is the lower section. This um, is what I wanted to share as a detail. I'm a lot more motivated and excited about the rockets I'm developing these days because I'm getting a little bit closer to having something that's considered a production value unit. I kind of have to work full time as a mechanic, although I'll be passing out flyers tomorrow as a as a handyman. Man, if just working for myself as a handyman, I don't really care, whatever it takes. Also, I want to let you know, I, Jason David Wampler, am going to be going back to school to finish my degree in mechanical engineering. I'm beginning my first goal is to get a Bachelor of Science Mechanical Engineering, and I cannot believe Bachelor of Science, you gotta have 120 units. I mean, a master's, you probably have to have double that, and a PhD, so 220. So PhD, I think you have to have almost 500 units of engineering. So, um, I mean, I want to get a master's. I was thinking and kicking the tires on getting a PhD in mechanical engineering, but you know, so my first goal, I'm going to Long Beach State University to pursue my Bachelor of Science in Mechanical Engineering. That is a for sure thing. Starts in summer. Um, I'm interviewing for a couple of jobs on Monday. Let's see, as a mechanic, and gentleman's supposed to be calling me tomorrow about a job as a smog technician, as a smog inspector. I have to take a test, but he said he's willing to pay for the test. I'd make up to $45 an hour, which would be wonderful because I could work part time and concentrate on the rockets. This is only part of what I want to talk about today. This is the attachment system for the rockets, and um, it's unique. I want to show you something. I've shown you this before, but up to this point, I'm more excited about the rockets. I'm closer to building a rocket that's going to actually work. That's a working prototype rocket. I still have some hurdles to overcome. This research on structural materials, motor attachment system, anchor spools. I've got everything pretty much down pat. I've even done materials research, and I found certain types of plastic that I got to tell you, American plastic is stronger than Japanese steel. Basically, American plastic is Americans in the United States. This country makes by and far the strongest polymer materials on the planet. There are plastics that some American industries make that are twice as strong as sheet metal. The Chinese sheet metal would bend and break and tear. And there are certain types of, triple, quadruple boiled uh, PTFE polymers and PTFE, I believe, polyteflon polymers that made by companies by I guess DuPont, not Alcoa. Alcoa is aluminum, but DuPont and other Dow and other American chemical companies that are just outrageously strong plastic materials. I'm kind of kicking the tires on, maybe Honda's going to experiment with making engines out of these reinforced polymers, and and reinforcing the stress areas with steel and aluminum. But it's not a far stretch to imagine um, making a water-cooled four-cylinder 1.5-liter engine out of an 8 times high-carbon baked or high-carbon boiled and purified high-strength polymer. And God's honest truth is there's some types of carbon polymers that are so strong it just boggles the mind. They're as strong as, if not stronger than, cast iron. So that's the way of the future. How easy is it to mold and machine these parts and make engines out of them? Well, the future only knows, and that's left to us, the mechanical engineers, to explore with these materials. Anyway, back into rockets. The attachment, the fuselage itself is 1, 2, 3 parts. This is a wasp waste, single engine area. The nose cone I have to make. We're gonna discuss nose cone manufacturing techniques later on, and that's the forward anchor spool. The rear anchor spool is going to be an episode itself. I want to show you how to make anchor spools that really work. Um, the other thing is there's a tool that I need to make. I want to get I want to make a low pressure air compressor system with a spit wand that you can extend down the inside of this tube so that you can do long distance spitting of liquid cyanoacrylate to glue the anchor spools in place. However, there are construction methods where actually I could probably take this lower section apart and install the anchor spool from the backside and then reinstall this section. This section right on top of the smaller transition section is where the anchor spool is going to sit. So I just kind of just going back and forth discussing the anatomy of this rocket. So we've got the nose cone here with an eye bolt and a nut and a washer. There's an approach to make this. Actually, a couple different ways to make nose cones. We'll have episodes on those. That's going to be it's going to be attached to forward shock cord, parachute here, anchor spool here. I can make a mosquito boom air powered uh, glue injection tool, but because I just figured out the section itself hasn't been glued. If this has just been taped on with 2 screws or tapers, you take these screws out and you pull against the tape. You put the anchor spool in with the lower shock cord, and the nose cone has the upper shock cord, and in between the two goes the parachute. And then you put the anchor spool in the bottom, and then you put this transition back on. You don't need the glue boom tool to glue the anchor spool in place. This area is just kind of bare. I want to show you the detail of this. This is an MPT. This is a gray plastic MPT thread. It's 1/2 inch. If you could see that right there, and that's anchored in with what's called double-sided tape. But I just realized something. But if I want to be consistent in my engineering, I'm going to have to do drill the holes and do the two countersinks and drill and countersink this section as well, because this threaded male portion, the MPT, gray MPT thread, is what holds the motor housing in place. And of course, the motor housing, I have to do the same thing, although being that it's slightly larger, either I'll use larger screws or I'll do 4. But I'm going to attach this guy to this section, this guy to this section of fuselage using this construction method, these 2 screws. And you need a drill or a Dremel tool with a speed control, and you need a countersink tool. I made a Dremel tool, custom Dremel tool in a box, with a power converter, a power indicator, an AC plug that lights up, and a foot pedal that varies the speed of the motor. I kid you not, this thing is awesome. I had no idea that it was going to be variable speed, and this thing has been Frankenstein with new and used parts. The power supply is actually, I think it's like 19 or 24 volts for variable neon supply, but the pedal itself varies the amount of voltage and amperage going to the motor. It's a little 5-volt Dremel motor, so now that it's variable speed, it'll last longer than the last one I made and used. And it's a custom job. It looks a little Frankenstein, but it absolutely works and it just works bitchin'. And that'll be another episode. Um, um, I know these are dry episodes. I hope that my enthusiasm is kicking up just a bit. I do wear glasses, by the way. I have nearsighted vision. I'm nearsighted and farsighted. So at 56 years of age, I may look and act a little bit young, but stuff's breaking. Um, so this has the female end of the NPT thread. I don't know if you can see that in there like that. I got double-sided tape in there too. I'm just going to go in. Oh, you know what? I have to be careful about this. This NPT section, I think, extends into the body. One thing, if I'm going to go in with screws in this threaded, I can't do it with the threaded section in there, because if I run into the threaded section, that's going to interfere with it threading onto that section. So this extends on up in the body a little bit. So I'll just do it a little farther up in the body with longer screws. Just be careful to avoid the threaded section. But the reason I do that is because of this. This is the motor housing. Now, I know what you're all thinking too, that you're going to create a boundary layer cup type of drag coefficient in this. So what I'm going to do is we're going to show you how to fabricate a section ring for here, so that the air flows around it. It does a cup in there. I might just build it up with plastic and sand it down. Or I might build up a Bondo and sand it down. You can use that too. The lightweight Bondo works great. Let me take this removable motor section off, because I want to show you something. I spent about half an hour walking around. I spent about half an hour walking around Lowe's. By the way, Lowe's on 120th and Crenshaw in Hawthorne, right next to SpaceX. Those guys are fantastic. You have some of the best, nicest, kindest workers at Lowe's. These guys are just absolutely dialed in on customer service. They're just as friendly as all get up. They're just on top of things, and they're just as helpful as they can possibly be. I can say the same thing about Home Depot. I'm not going to pit Home Depot against Lowe's. Frankly, I need both. I need Lowe's and I need Home Depot. But in this, that's the female MPT threaded end. This is the business end. If you can notice that, there's a little hit there. This is a plumbing extension. This is part of a kit for assembling under sink plumbing passages. If you're installing in sink raider, or if you just want to join two sink sides with the main drain going out to the sewer outside of the kitchen, or if it's a bathroom fixture, it's the same difference. This is what I spent. Goodness gracious, everything just one thing I want to talk to you about, I kind of bitch and moan about this. Manufacturers are now integrating mold release wax uh, in with the plastic that they cast, so they don't have to keep coating the surfaces of the machines that mold these plastic pieces. The reason they do this is ease and speed of manufacture, which lowers overall manufacturing costs, which increases profits. But you know what? Make stuff is absolutely slick as a hockey puck. And I got smooth machinist hands. 56 years old. My fingerprints are gone because 41 years of working on cars and 26 years building rockets. No, I cleaned up my hand. I took a palm sander in my hand. I was thinking to clean all the grit up. No, it was taking all the dead skin off my palm of my hands. Now they're halfway clean instead of completely dirty. But getting back to the point, this is the stuff that I was walking around in Lowe's looking for half an hour. And I finally caved on this stuff. This stuff is about 30 millimeter inner diameter. Why do I say 30 millimeters? Okay, folks, the three. Let's discuss the three sizes. Actually, building small rockets. The three sizes I'm going to be fooling around with right now: 18, 24, and 29. I'm not going to build that many 18 rockets with 18 millimeter motors. I got to tell you, you can't do much with an 18 millimeter motor. You just can't. 24 millimeter motors are a little bit more serious. The Estes and Quest, the A, B, and C motors are mostly 24 millimeter. Some of the smaller stuff, the 18 millimeter motors, God's honest truth is you're going to get about 400 or 500 feet of performance out of a rocket like that. And that's little kitty stuff. That's stuff you go to the corner park, you light a rocket off, they'll just go up a couple hundred feet, come back down. It's not going to hurt anybody. Those rockets are black powder rocket motors. They're still rocket motors that are dangerous, don't get me wrong, but there's not that much excitement in them. So this is the stuff I'm working with for they're 29 millimeter motors. Why do I say 18, 24, and 29? Because the standardized rocket motor sizes, both single use and rebuildable, and guys, take notes of this. It starts with actually Micromax motors. I don't even like those, but it starts with 18 millimeter. 18 millimeter is the smallest diameter rocket motor you can get, almost exclusively available in single use. 24 millimeter rocket motors you can get in a reload kit, or you can get single use. Next size up is 29 millimeter. You can get those single use or reloadable. Now, when you go up to 38 millimeter, most of the time you can only get reloadable. I'm not quite aware, unless they're homemade. I'm not quite aware of anybody who makes single use 38 millimeter motors. It'd be too expensive. It's just wasteful of materials. After 38 is 54. 54 millimeters is the next size up. After 54 millimeters is 75 millimeters. 75 millimeters is the next size up. I don't think there's a size between that. 75 millimeters is fairly large. That's almost about the size of a very, very small motorcycle piston in diameter. The next size after 75 millimeters is 98 millimeters. And 98 millimeters, folks, let me tell you, that is actually the size of a regular automobile piston in diameter. A 98 millimeter motor is something that you would probably only have access. You only have access to if you're level 3 certified. So let's discuss level 1, 2, and 3 certification really quick. Level 1 certification gives you access to everything up to I-200s, everything up to 200 nms of impulse. Doesn't matter, you can get an I-200 38 millimeter or 29 millimeter. If it's 29 millimeter, the motor's actually going to be probably about this long. Dr. Rocket made the Desert Fire 29 millimeter I-200 motor, or motor casing that houses I-200 motor. And that I-200 motor is what I got my level 1 certification with back in 2003. Andy Werner, Plaster Blaster, Plaster City, north of uh, San Diego. My dad was with me. He took pictures, and I gave the picture away. I have my level 1 certification. Um, you have your level one certification either with NAR or AAA. I got mine with AAA. Andy Werner. Andy Werner's a great guy. Shout out to Andy Werner for seeing this. Um, you keep it for the rest of your life. I have access to 29 or 38 millimeter motors up to I-200. So I-200 is past H-120. There's an H-160, H-170, but I think you get past you get past 160, it becomes an I motor. Level 2 certification, I took the test twice, I failed twice, and I had to build a rocket. You have to fly a rocket. I failed that twice, unfortunately. That gives you everything, I believe, through L. H, that's H, I, J, and K. No, it gives you everything through K. I believe through K 550, but it might be less. It might be only like a 450, like a JK 450. At the level 2 certification. Level 1 certification requirement, you simply build a level 1 rocket. Doesn't have to have electronics. You fly it, you cover it successfully on a motor that's bigger than a G80. It has to be in at least an H120. An H120 is 3 segments that would fit very nicely in this motor, probably something a little shorter like that. You fly it and recover it successfully meaning it doesn't land too hard enough to break anything. Level 2 certification, you take a test and then you fly and land something successfully. Level 2 certification, you may or may not need electronics, but it's recommended. Level 3 certification is different. You get access to specific impulse motors that are basically so powerful. They're basically as strong as military grade projectile missiles and rockets. This is serious stuff. Um, Technically speaking, you're supposed to have an LEUP. If you have a level 3 certification, you cross state lines, you have to have an LEUP, low explosive users permit. But that law is under fire right now because cars filled with tanks of gas, you're exporting an explosive across state lines as well when you travel across state lines in a vehicle. So I don't know. Maybe that law is under fire, maybe it isn't. Requirements for level 3 certification to give you access for anything above 450, 550 NMs on up to, uh, my goodness, 14, 15, 16, 1700, 1800 NMs of impulse, like an M1214. Very, very, very popular M engine. M is in Mary, 98 millimeter, more than likely. Those motors are about roughly 2.5 feet long. Again, 98 millimeters in diameter, so about the size of a small Honda Accord, a piston out of a Honda Accord engine. Um, and the Aerotech, which is a very, very popular manufacturer, not much of rocket kits, but reloadable motor systems. They make an M1214, which is very, very popular for people who want to get their level 3 certifications. Now, let's talk about this. A level 3 certification, that's the big time. Um, you're gonna end up building a rocket that's basically half the size of a telephone pole and is about roughly the same diameter and it's probably gonna weigh half as much as well. Level 1 certification, you build a rocket that weighs maybe 10 pounds. Level 2 certification, you build a rocket that weighs 25 pounds. Level 3 certification, you've got to document, you've got to audio and visual record yourself every time you work on the rocket. You've got to collect and save that video and audio recording of you building a rocket. You have to have audio and visual proof that you're building a rocket every step of the way. Those are laws. NAR and AAA stipulate the exact same laws. NAR and AAA have gotten together and they've stipulated that law. That's number one. Number two, it does have to have electronics because nobody makes commercial grade reloadable motor system that's 98 millimeters in diameter that has a separation charge filled with a small espresso cup full of black powder at the end of the motor. That's suicide. That's like setting off a small bomb inside the rocket. So, level 3 rockets, guess what? Level 3 rockets usually have more than two sections, two regular parachutes, two drogue chutes. Level 3 rockets usually have three sections. They have one, two, three different recovery spools, two different couplers. They have a main payload area with electronics, and they have two black product separation charges. They have four shock cords, two main parachutes at minimum, and two drogue parachutes minimum. And the rockets themselves are usually minimum diameter for a level 3 rocket because of fitment issues and the size of the motor itself. Remember, 98 millimeters, the size of a small piston and a small Honda engine. Minimum diameter, um, you're going to want laminar flow of heat. You want laminar flow of downward heat going around the engine. You don't want a 98 millimeter motor fitting snug in the body tube of a minimum diameter rocket meant for level 3 certification. Because remember, the two requirements for level 3 certification is you video and audio document you're building the rocket every step of the way, and then you've got to successfully launch and recover the rocket. And I forgot to mention level 1, 2, and 3 certification process. When I say recover rocket, you have to be able to fly it again. In other words, after it lands, you have to be able to reload it and fly it again without making any repairs, not even minor repairs, not cracks, nothing. Level 3 certification is serious business because an M1214, the M1214, your rocket will go what's called transonic, which means it will break the sound barrier, which means at altitude, when it gets to that speed, which is probably going to be very close to 2 miles up in the air, at roughly 1.5 to 2 miles in the upper atmosphere, you can hear cracking sound. It's going to break the sound barrier at roughly 750 miles an hour. Your rocket will go transonic. Level 3 rockets don't usually work if they don't go transonic because if they don't go faster than 750 miles an hour, they're probably not going to gain enough altitude to correctly complete the 5 stages of flight of a vertical launch rocket, which are, of course, takeoff, takeoff and under power, then coast, then apogee, then descent. Um, okay, so so boost phase, coast, apogee, descent, and recovery. So 1, 2, 3, 4, 5. I think that's right. But the level 3 rocket is not going to gain enough altitude to go through all 5 sections of the flight phase correctly and proportionally. There's proportions and ratios to every step of the way. Exponentially, your rocket's getting bigger, more powerful. It's going to go faster. It's going to weigh a lot more. Minimum weight. It's not a requirement, but usually the minimum weight for a level 3 rocket is a little under or a little over 100 pounds. Now, something that weighs 100 pounds, it's larger. Like larger animals need bigger cages. So you're going to have something that's going to go transonic more than likely. Now, why am I mentioning it? Well, for the obvious reason that if you build something that's transonic, I haven't built anything that's transonic yet because I can't afford G10 materials. Although I'd love to go on McMaster-Carr and just rack up, get a credit card with $10,000 credit limit and buy a bunch of exotic tubing material. G10 is an American grade classification, American grade light apple green fiberglass, which is incredibly resilient, strong material. Structural building process for level 3 rockets can survive uh, transonic speeds of 750 miles an hour at 250 feet up. You're going to break the sound barrier. Everything is going to have to be made out of Kevlar and fiberglass and reinforced epoxy. And also, you're going to have to use and employ fast stainless steel fasteners, thread lock things. You have to have the epoxy and gussets. You're going to have to watch how you build a rocket very carefully. And remember, the whole time you're carefully building a rocket, you got to be able to afford to record. audio and visual record yourself the whole time you're building that rocket. A level 3 rocket designed for transonic speed and all that type of laminar truncated pressure on the fuselage at over 750 miles an hour. You have to consider that you have to build the rocket exceptionally light and exceptionally strong. This poses a challenge for a lot of people only because they don't know how to add 1 plus 1 plus 1, and then, you know, they don't know how to do a math test with a pen in their mouth and juggle the apples with their hands. And folks, I'm going to tell you right now, for your level 3 certification, that's probably what you're going to end up doing. It is a really big deal. There's a magazine called Sport Rocketry. I'm not sure if it's still being published, but if it is, it has a separate special article almost every month that comes out. Who got their level 3 certification in the entire North American continent? We're talking about, you know, parts of Mexico, Canada, and all of the United States, and all the launch events. There's going to be one person that's going to successfully attain their level 3 certification. And I gotta tell you, if you meet these guys and talk to them, you'll find out they're the real deal. They're actual rocket designers and scientists. They deserve to be called Dr. Rocket. Okay, but the Sport Rocketry is a periodical, I believe, only comes out once every 2 months, and they only have one article every 2 months about somebody getting their level 3 certification. So why am I saying that? It's a really big deal, folks, and it means a lot to me. So, having talked myself into it, I'm going to go for my PhD in mechanical engineering, which is 1, 2, 3 credentials away because I don't even have a certificate, but I have 35 transferable units. So I'm going to go for my PhD in mechanical engineering. Guess what? I'm also going to go for my level 3 certification, but bachelor's and master's first, level 2, first, etc., etc. Anyway, so last phase of what I want to show you now that I've lectured you about the process of levels 1 through 3 certification. The inner diameter of this pipe, this is made by Charlotte Pipe, and I cannot see into the writing. This is 200 psi burst pressure PVC pipe. Don't get me wrong, PVC is great stuff, but it's not flexible like black ABS is. Be careful. PVS has some interesting properties. What am I going to say? PCB, polycarbonate vinyl. No, it's PVC, excuse me, polyvinyl carbonate. Structurally very strong, but guess what? It cracks. It doesn't flex like ABS does. ABS has a non-solid foam core. ABS is thick-walled. ABS is lighter than PVC, but it's thicker, it's harder to work with a machine. We'll put that in episode 2, how to use descending mill and a limit stop to go ahead and machine couplers into thick-walled ABS. Instead of using separate couplers, you dovetail the inner diameter and the outer diameter of the 2 main pieces of ABS. I've done it before. It works, but only on smaller diameter ABS pipes. Anyway, so this stuff is 200 psi burst PVC, polyvinyl carbonate. Okay, so if you run over this, it'll bend a little bit, it'll flex, but guess what? Enough impact, it's going to crack. This stuff does not flex at all. The other thing is, I'm not quite too sure how well it's going to hold up under heat. So when separation charge goes off the end of the motor, inside the inner diameter of this pipe, which is going to fit into this screw-on housing here, like so. Not even a whole lot of space at the end. I may have to explain some things. So that's more materials research because I don't want anything to melt. I want this rocket to be good for at least 50 launches. So anyway, that's that. I'm just doting over rockets. You think the rockets are the only thing I like. However, for whatever reason, I've been caught up in the magic of launch controllers. Now, we're at the 34-minute mark. I don't think you guys are going to watch me or listen to my ugly ass anymore. This is a rudimentary through-box launch controller. apparently it's not fancy enough to catch the attention of anybody on eBay. I just happened to cannibalize a model car, and I've got myself a big old honking 6-volt battery. Check the voltage of that. This is now going to be an internally powered, your internal battery powered control unit. I'm converting it. This is the 6-volt. I got a 7-volt inline charger for it, which is basically a rectifier, which basically converts AC electricity into DC electricity. And there's a certain rating output for it. Input is 120 volts, 60 hertz, and roughly 7.77. Oh no, and then output is 7 volts. Input is 120 volts, 60 hertz, 7 amps. Output is 7 volts. This is an output of 7 volts and a few amps. So really, that's perfect for charging this battery. Obviously, it warms up. I won't let it bubble over. It's a sealed lead battery. I got this out of a kiddie car that somebody's thrown out. Los Angeles, everybody kicks it to the curb, so we'll wire it tonight. 9:20. Okay, so that is my masterpiece, but I just shipped off one that I didn't do anything about, and I could have found a video about this. Color coordinated cables, 2-mode gray with a weather station, and a row of USB connectors, AC powered, so you can charge your laptop, your phone, when you have the unit and you're using it to launch rockets. Okay, but you got to have an AC plug to plug it in. So usually at these rocket launches, it'd be a better part of wisdom to have a power box or to have a small gasoline powered generator to run things. Another episode, we'll talk about that later. I just want to talk to you about this lovely rocket that I'm building over here. When I get done with it, I am going to list it on eBay, but it gets to the point where I really want to go to a rocket launch. I'm going to try and launch it, and if it busts, then I'll just build another one, cancel the listing, and list another one. That's how I do. But so far, so good with the launch controllers. I'm actually selling them. I'm not selling them for a price that I want, but if I can create brand loyalty, brand familiarity, and I get some happy customers to talk me up, talk up sales, then I can put it in a bid format and people can bid against each other, and that way I'll determine the market value of these magnificent creations of mine. They're taking on lives of their own. I don't have pictures of the other two I just sold. I just shipped off an orange one. I just shipped off that beautiful gray one, which is just exceptionally exquisite. I mean, it looked professional grade. And they got this black fella here. Excuse me, I've got that doesn't sound right. I've got this black controller here that we convert tonight to battery power. So it's going to have an internal battery power with charger. Anyway, that is pretty much that. My workstation inside my 1999 Toyota Sienna has evolved to its highest point. I need to get a different type of stool. I want to replace the carpet, but frankly, right now, I don't have the money. So thanks a lot. It's 38 minutes, 36 seconds. My name is Jason Wampler. I hope the sound comes in. Hit the like button, hit the subscribe button. Leave any comments or complaints. Hurt me, baby, make me write bad checks. But I don't have a tagline. I don't have a tow line. It's just, build and enjoy. But that don't make no sense because I don't think anybody wants to build. Anyway, I'm going to get on. I'm going to load this video. I'm going to finish retrofitting the new controller. I've got to, I can keep it for myself, but I think I'm going to go ahead and list it on eBay. If I don't get enough money for this one, I'll just wait till I build another controller. And then, I'll sell this one or I'll doll up the new one I build. But, so the other thing is I want to make sure I get a good amount of money for this. I don't want to just have somebody offer $1.25 for it because it's worth more than that. It's worth a lot more than that. All right, my name is Jason Walkley. This has been another episode of The Rocket Minute. Hit the like button, hit the subscribe button, and for God's sake, somebody speak up and leave a comment. All right, we'll see you later. Bye-bye.